Okay, we're going to apply some of what we've learned to solving. We're going to use the square root property. So first we're going to discuss what the square root property is, and then we're going to do some problems using it. How's that sound? The square root property says if I can isolate the squared term, then I can take the square root of each side. The only thing I have to remember to do is that the constant, which is usually on the right-hand side, because it could have been negative before it was squared, needs to have a plus or minus in front of it. So let's see what that means in terms of using it to solve. Notice that I have x squared is equal to 25. So I'm going to take my x squared is isolated, so I'm going to take the square root of both sides. And then anytime I take the square root of something squared, it cancels, so I get x is equal to plus or minus 5. So we would write that as 5, 0 and negative 5, 0. Okay, x squared equals 54. My x squared term is isolated. So what I can do is I can take the square root of both sides. 54 is not perfect, so I can do start dividing by primes, and I get 3 and 18 and 3 and 6. And 6 is not prime, but it is a composite that doesn't have any perfects. So I get a pair of 3's. So I get x squared is equal to plus or minus 3 root 6. So my answer would be positive 3 root 6. And then negative 3 root 6, 0. And we're going to leave these in exact form, not decimals. X squared is equal to negative 49. I'm going to take the square root of both sides. And now I'm going to have a negative under my radical, which means that I have to take out a complex number, which is I. So I get x is equal to the square root of negative 1 times the square root of 49. This is I. And then, that's a times, this is 7. So I get plus or minus 7i. Now, because these are imaginary, these are not x-intercepts. When you get an x is equal to a plus or minus a negative, or a negative square root, or with an I, we don't write those as x-intercepts. We just leave it as x equals 7i and x equals negative 7i, just like that. All right, now I have x squared minus 2 equals 25, so I'm going to add 2 so that I can isolate my x squared, and then I get x squared is equal to 27, and then I'm going to take the square root of both sides. 27 is not perfect. It is 3 and 9 is perfect. So this is x equals plus or minus 3 root 3. So we would get 3 root 3, 0, and negative 3 root 3, 0. On number 5, I'm going to move my 9 over. So I get 3x squared is equal to 15. X squared is equal to 5 when I divide through by 3. Then I'm going to take the square root of both sides. So I get x is equal to plus or minus root 5. So that gives me root 5, 0, and negative root 5, 0. Okay, I don't have an imaginary, so these are actual exact solutions. Now, number 6, this is just a little bit different because I have a square after a parenthesis, but I can still take the square root of both sides because this whole thing is being squared and it's isolated. So don't multiply it out, just take the square root of both sides, and whenever you take the square root of something that's being squared, you just get that thing that's underneath the radical. We're going to take the square root of negative 32, and then I'm going to get x minus 3 because these two things undo each other. X minus 3 equals I root 32. Actually, that's plus or minus I root 32. See if I can squeeze that in there. Okay, I'm going to simplify root 32. That's 2 and 16. 16 is 4 and 4. There's a pair. So I get x minus 3 is equal to plus or minus 4i root 2. Ooh, that is cramped, cramped, cramped. Let me see what I can do. Sorry about this. X minus 3 is equal to plus or minus 4i root 2. Okay, and so now we have to figure out how to get that 3 over. It's really quite simple, and you always want to remember to put it in front of that plus or minus. So I get x is equal to 3 plus or minus 4i root 2. So that gives me, and remember, we're not going to write these as ordered pairs because we have an I. X equals 3 plus 4i root 2, and x equals 3 minus 4i root 2. Okay, that's the square root property. All right. So we're going to talk about the quadratic formula in the next video.